We have to simplify the square root of 36 plus square root of plus 2 root 18. Okay, just like in now, here we cannot do this directly. If we do that with the calculator, we're going to have an irrational number. The same thing with this one, we're going to have an irrational number. So just like in our first example, we'll look for the factors, numbers that can replace 36, numbers that can replace 36 but have a square root. So divide 36, we'll look for the factors of 36. If we divide 36 by 3, 3 into 3 will give you 1, 3 into 6 is 2, 3 can go, 3 into 12 will give you 4, 2 can go, 2 into 4 is 2, 2 can go, 2 into 2 is 1. So 3 times 3 is 9, right? 2 times 2 is 4. So 9 times 4 will give you 36. So we now have 9 times 4 to replace 36. Plus, we'll do the same thing with this, with 18. If we go with 18, we'll have 18. 2 can go, 2 into 18 is 9. 3 can go, 3 into 9, give you 3. 3 can go, 3 into 3 give you 1. So 3 times 3 is 9 times 2. So 18 here was we can replace 18 with what? 9 times 2. So we now have 2 root 9 times 2. So quickly take this out of our sheet. We now have this. Now, following the product rule, we can write this one separately because we record that square root of AB can be written separately as square root of A times square root of B. Similarly, we can write this to become square root of 9 times square root of 4 in one piece plus 2 bracket open square root of 9 times square root of 2. Square root of 9 is 3. So we'll have 3 times 4 will give you 3 root 4 plus 2 into square root of 9 is 3. 3 times 2 will give you bracket open 3 root 2. Alright. Here we have 3 root 4. We have 3 root 4. We have 3 root 4 plus 2 times 3 give you 6 root 2. Root 3, root 4 and root 2, they are not the same. So we cannot add, we can't do anything with this expression because like you're having x, 2x plus 2y, right? Though 2 and 2, they are numbers, 3 and 6 are numbers, but the root 4 that is added to them and the root 2 that is added to them, they are not the same. Same with x and y, they are not the same. So this is how far we can actually simplify this expression. All right. In front of us here, we have two solid brackets to solve. Actually, they are the same, but if you look at it, here we have plus minus, here we have plus plus. We want to see what to arrive at in solving these two expressions. We expanded the bracket for sod. Just like we do for, if you want to expand bracket, just like we do if you have x plus 3 bracket x minus 3. X here will multiply everything here by saying x multiply everything here, x minus 3 plus 3 will multiply everything here, 3 bracket x plus 3. The same way, we're going to use this 1 to multiply everything here. We'll also use this root 3 to multiply everything here. All right. So let's go ahead and do that. We'll use 1 to multiply everything here. We'll now have 1. We have 1 bracket. Whatever we have here, 1 minus root 3 plus root 3 bracket 1 minus root 3, right? 1 times 1 will give you 1. 1 times minus root 3 will give you minus root 3. Now, next, we'll now expand this one. Plus root 3 times 1 will give you plus root 3. Then root 3 plus times minus will give you minus. Root 3 times root 3 will give you 3. How did that come? Root 3 times root 3 is equal to 3. How? Root 3 here is 3 raised to the power 1 over 2 times 3 raised to the power 1 over 2 From law of indices, if you recall, if you have these two base to be the same, you take 1, you add the powers. 1 over 2 plus 1 over 2, half plus half is equal to 1. 3 raised to the power 1 is anything as 3. That's how we got root 3 times root 3 to be equal to 3. Having established that, so we now have minus x here plus x, that is minus root 3 plus root 3 will give you 0. That will leave. So you now have 1, you now be left with 1 minus 3. 1 minus 3 is minus 2. Okay, let's try the same thing for this other bracket, expansion of bracket on this other side. So 1 here will multiply everything inside it. 1 here multiply everything here, while root 3 will multiply everything here. So we'll have 1 into 1 plus root 3, bracket open, plus root 3 into 1 plus root 3, bracket close. 1 times 1 will give you 1. 1 times root 3 will give you plus root 3. Plus root 3 times 1 will give you plus root 3. Root 3 plus times plus will give you plus. Root 3 times root 3 will give you 3, just like we've already established. So we'll collect like terms. 1 and 3, they are just numbers, they are alike. So we'll have 1 plus 3. Alright. Then plus root 3 will give you 2 root 3. 1 plus 3 will give you 4 plus 2 root 3. Okay, here we ended up with an integer, which is minus 2. Here we still have sod. This one is called a mixed number. Numbers. We have numbers mixed with sod, right? Here we have a whole integer. So it's found that this and this, they are opposite expression. They are called conjugates. Here, plus 1 plus root 3 is the conjugate of 1 minus root 3. To have a conjugate of a number, you reverse the operation in between them. For example, I want to find the conjugate of 1 plus root 3. The conjugate will now be 1 minus root 3. Conjugates are ways we use to rationalize sod, right? We use to simplify sod so that we can end up having an integer. If you have a sod, you want to rationalize it to become an integer, to become a whole number, you multiply by its conjugate, right? X minus root 3, the conjugate is x plus root 3. So that's for conjugates. So you just multiply with the same expression, but you change the operation in between the expression. When you do that, when you expand that kind of bracket that has a sod in it, what you end up with is a rational number, a whole number, such as this. So the difference is just that this one is multiply itself with the same number, with the same expression, while this one is multiplied itself with a conjugate. Changing this plus here to minus here makes this one to become the conjugate of this other one here. And when they multiply, I'm repeating myself again, when they multiply, you have a whole number as your final answer. So that's why I put just this versus this to explain what conjugate actually is to you. This remains a sod, is a mixed number, a whole number added to a conjugate, added to a sod, right? We call it mixed number. Here, we're able to evaluate our expression such a way that we now have a full whole number as our final answer, which is minus 2.